I am Dr. Indra, Assistant Professor, Department of Mathematics, SRM Madurai College for Engineering and Technology. Today I am going to talk about testing of hypothesis. Hypothesis is nothing but the statement, and the decision making procedure about that hypothesis is called hypothesis testing. Before entering into solving the problems, we should know about null hypothesis and alternative hypothesis. Null hypothesis is denoted by H0 and it is the hypothesis of no difference. Alternative hypothesis is denoted by H1 and it is the hypothesis of the difference between a statistic and the parameter or between two sample statistics. For example, H0 may be mu is equal to mu naught and H1 is mu is not equal to mu naught, which is two-tailed test, or mu is greater than mu naught, which is right-tailed test, or mu is less than mu naught, which is left-tailed test. Next, the definition for critical region. Critical region, simply we can say region of rejection. A region corresponding to a statistic T in the sample space S, which amounts to rejection of the null hypothesis H0, is called as critical region or region of rejection. Next, we are going to see about level of significance. The definition for level of significance is nothing but the probability that the value of the statistic lies in the critical region, which is called level of significance. This is the table values of Z alpha. So Z alpha values are 2.58, 1.96 like this. If it is two-tailed test and 1% level of significance, the value of Z alpha is nothing but 2.58. Suppose it is 5% level of significance, it is left-tailed test, means Z alpha value minus 1.28. These are all the values of Z alpha. The definition for type 1 error is, if it is H0 is rejected, but actually H0 we have to accept, means that is type 1 error. After calculating, we get H0 is accepted, but actually H0 we have to reject, means it is type 2 error. Large sample tests. What is large sample test? There are two types of test. One is large sample test, second one is small sample test. If it based on sample size n. Suppose n is greater than or equal to 30, it is a large sample test. Suppose the values of n starts from 1 to 29, that samples are small samples. The test is known as small sample test. Next, we are going to see about test for single mean. The procedure for testing single mean problem is, first we have to fix null hypothesis. H0 is equal to mu is equal to mu naught. Alternative hypothesis, it may be H1 mu is not equal to mu naught. Two-tailed test, or greater than mu naught, right-tailed test, or less than mu naught, left-tailed test. Next, we have to find test statistic Z. Z is nothing but the formula x bar minus mu by sigma by root n or s by root n. If it is sigma is given, the formula becomes x bar minus mu by sigma by root n, or s is given, the formula x bar minus mu by s by root n. Then after finding Z and Z alpha, we have to compare Z and Z alpha. Z value is less than Z alpha, H0 is accepted, or Z value is greater than Z alpha, we have to reject H0. There are two problems we are going to see based on test for single mean. The first problem is, a sample of 900 members has a mean 3.4 centimeter and standard deviation 2.61 centimeter. Is the sample from a large population of mean 3.25 centimeters and a standard deviation of 2.61 centimeters. First, we have to test the hypothesis, which means we have to find H0 is accepted or rejected. For that purpose, we have to find Z. So, formula for Z value is x bar minus mu by s by root n. So, what are the given terms? The number of terms is nothing but n. So, n is equal to 900. Then, what are the given terms we have to see? First one is for sample values. A sample of 900 members has a mean, which means that one is sample mean. So sample means we have to denote as x bar. So x bar is equal to 3.4. Then standard deviation 2.61. It is also from sample. So sample standard deviation value is 2.61. Next, population mean. It is denoted by mu. So mu value is 3.25. Then we have to fix H naught. H naught is nothing but mu is equal to 3.25. 3.25 is nothing but the population mean. Next, H1. Mu is not equal to 3.25. So it is a two-tailed problem because it has no increase, decrease. That value, that word is coming now. So we have to fix that one is right or left tailed. That type of words is not there in the problem, means it is a two-tailed problem. So after writing all the values, we have to find Z value. The formula for Z is x bar minus mu by S by root n. Just substitute all the values, we get Z value. Then comparing Z value with Z alpha, we get modulus Z is less than Z alpha because Z value is 1.724 and Z alpha at by 5% level of significance, two-tailed test, the value is 1.96. So comparing these two values, we get Z is less than Z alpha. Then we conclude H naught is accepted, which means there is no difference in sample mean and population mean. This is our conclusion for first problem. Second problem. A normal population has a mean of 6.48. So this 6.48 value is for population. So this one is population mean. And standard deviation of 1.5. This value is also for population. So this one is sigma value. So sigma is equal to 1.5 and mu is equal to 6.48. And next, in a sample of 400 members, so number of members is nothing but n. So n value is 400. So it is greater than 30. So it is a large sample test. And only one sample, we are going to deal about only one sample. So this is a test for single mean problem. Is the difference significant? So we have to check H naught is accepted or rejected. Fix H naught. H naught as mu is equal to population mean. That value is 6.48. Next H1. Mu is not equal to 6.48 because this is a two-tailed problem. How we check this one is two-tailed problem or right-tailed or left-tailed means if it is the problem contains increase, exterior, that type of words is there in the problem, means that one is right-tailed problem. Suppose less than, decrease, that type of words is there, means that is left-tailed problem. That type of words is not there, means that is two-tailed problem. So we can fix mu is not equal to 6.48. Next, text statistics formula is Z is equal to x bar minus mu by S by root n or sigma by root n. When we use sigma by root n, because sigma is given, right? So we have to fix sigma by root n. So just substituting all the values, we get Z value is equal to 3.6. Then comparing Z and Z alpha, we get H naught is rejected because Z value is greater than Z alpha. So these two problems are the examples for test for single mean. Okay, thank you.